Hello and welcome to this webinar. We're going to be looking today at why a number of C# developers are now choosing Delphi for their mobile development. And as we go through today, I'm going to be your host. My name is Stephen Ball. I am a product evangelist here at Embarcadero for Rad Studio, which includes Delphi and C++ Builder. And I'm also the associate product manager for the IoT award-winning database Interbase, which works really, really well. We have a number of Visual Studio and Rad Studio customers using Interbase. If you do have any questions and you're watching this live, please feel free to go and use the GoToWebinar chat panel. Otherwise, feel free to drop me an email on stephen.ball@embarcadero.com. And also, please hook up with me on Twitter at Delphiable and with my blog delphiable.co.uk. So the real desire from developers is to be able to write their application and get it running on as many devices as possible, as quickly as possible. You know, the dream is to have this single code base that works across multiple platforms, and that brings with it a number of challenges. There's a lot of differences in terms of the growing plethora of devices that are out there, from iPods to iPhones to small tablets, phablets. It's a real big challenge to get the same applications running across multiple different devices, not only because of the different screen sizes and the capabilities of those devices, but because the platform user experience and the platform APIs that allow you to do the same type of functionality on different platforms range vastly in the way they're implemented across different devices and different OSs. And with the world today for mobile, as developers, we need to be aware of the differences of different OSs and how they work if we want to get the best out of those platforms. So we really have, on one side of the story, vendor tools, so tools provided by people like Apple, who provide Xcode for developing applications to run on iOS. And then we have Google, who are kind of helping Java developers build with Android Studio and with Eclipse. And then obviously Microsoft have got their native tools as well, which primarily have been for the traditional desktop platforms, but you can do Windows Mobile Phone development through them as well. On the other side, we have the multi-device programming languages. Now, typically these have been scripted languages, and there's a lot of HTML-based options out there, an absolute plethora of them. A lot of them working with JavaScript underneath the hood, which is great, but has some challenges around compilers and everything else like that. And so let's have a look at the pros and cons for both sides here. The pros for the true native version is obviously you get a native user experience. And when the developer has outputted their code, the end user is going to be running on an application they feel at home with for the platform that they're experiencing. And this also has native performance, which gives you the best feel, and that's really, really important. There's plenty of case studies looking at why not having a native user experience actually really degrades the end user experience and the time they spend using the applications. Now, because it's native code, it's very secure by nature. It's compiled. There's no runtime libraries or anything you can go and modify that your application is going to be using. Then, it's compiled down to the metal. The cons, in terms of taking the true native approach, because it is by far the best approach to have, is that you end up with multiple code bases, which means you've got multiple QA cycles, multiple teams to support it, multiple skill sets that you need to keep updated, which means you've got a much higher development team cost just to be able to produce the same thing on iOS and Android, for example. The other half of the story is really one development team with a much lower development cost, a much faster time to market. You've got a single code base, in essence, and that's really some of the big attractiveness of the HTML5 solutions that are out there. Using things like Cordova and PhoneGap to be able to produce a native shell that then has all the HTML stuff shoved inside it. And this allows some access to the system, not full access, but it does allow some access to the native layers on the devices. But it does come with a big downside, and that is that you are always interpreting what's been written. And the downside of that is that it's actually one of the big hack targets that people take is to reach into these applications that are out there and modify the HTML and the JavaScript elements that are in those. So you do end up with a very unsecure application, and it's a lot harder work to be able to do some of the native storage and the other kind of things that the true native applications just make very, very simple. So looking at what people have said about trying to go kind of the HTML5 and the Java route to getting things out there. Mark Zuckerberg said, the biggest mistake we made as a company was betting too much on HTML5 as opposed to native. Facebook's share price soared by, I think it was around about 14% when they switched over to a native application from the original HTML5 application they had for mobile. Because people were spending so much more time on the mobile applications, they're able to serve so much more mobile content and advertising, and hence make a whole load more money. Been similar stories with LinkedIn. There's been great quotes from kind of Apple Insider about the unbundling of Java runtimes, which plugged a whole load of the security vulnerabilities which came from having virtual machines, which is the kind of other half of the multi-device scripted kind of side of things. And Java still is in a lot of pain around the practical use of it as a solution because of the number of security vulnerabilities around it. In fact, one of the big security vulnerabilities on the Android platform in the last year has been around a Java vulnerability in advertising plugin that was probably one of the most popular ones out there in probably about a quarter of the applications on the App Store. And security analysts didn't actually name the plugin because they didn't want to have people target the applications that use it too much, but instead showed ways to be able to plug the issues that it was causing. But what we are shaping here with Delphi, and a few others are trying to follow, but are quite a way behind, is the true native approach. Now, true native brings the best of both worlds. We have a native user experience, native platform performance because we are compiling using the same compilers that Xcode uses. And in fact, we actually get faster performance on Android because we're compiling down to the NDK, which is what the games developers use. So we're bypassing pretty much all the Java layer. This means the applications, in fact, the only Java bit on a Delphi application is a little stub launcher to launch the native application. Now, this means our applications are very secure by nature. They're compiled code. There's no vulnerabilities around scripting languages within them. There's no virtual machines that can be modified. And this means we have a much faster time to market as well, because it is the single code base. One team can learn, develop, and get out there. And this lowers your time to market. So just to picture that, this is where we are with ARM-based binaries getting out onto iOS and Android. Whereas with HTML5 and JavaScript and CSS, you're kind of running through an interpreter. And also if you're doing kind of Android development, or even if you're doing some development with Xamarin, you're actually building into virtual machines that are then running on the devices as well inside your applications to then get out into the chipset. So there's an extra layer in there. So why is this all important? Well, today you can get to here using Delphi. And the reason that's important is because for C# developers and people using .NET, it feels very familiar. Delphi feels exceptionally familiar. It comes from common ancestry, which means across both languages, across C# and Delphi, they're structured, they're event-driven, they're Very, very similar in terms of their object-oriented approach. They're imperative. Delphi and and C Sharp have strongly typed. They're both strongly typed languages. They have static types, dynamic types, generics, runtime type information, reflection. In terms of the way that you build using the user interface, you can use components with properties, events, and methods driving underneath those. Method events-driven development. They're both rad. And it's very easy to see why they have such a common single ancestry when you know that Anders Helsberg is the guy behind both languages. Now, he's commonly quoted as saying about his work with C# that we all stand on the shoulders of giants. And that's very true in terms of bringing the best of what he's worked on to forming C#, which is why so many C# developers feel very at home immediately, getting the best out of what Delphi can offer them to supplement their existing tool chain and tool set, keeping their backends running with .NET, but then linking into them with mobile applications that are written using Delphi. Now, a colleague of mine, Jim McKeith, has done a really good video, about half hour long, on C# for Delphi developers, and it was done a couple of years ago now, but it's got some really good structural bits in there, so I'm not going to recover that here, but I do want to jump straight into the IDE, and we can see just how familiar it feels with property method event development, and how you can just get straight on. So here I'm in the IDE. This is the default layout. You can, obviously, I think the tool palette's normally up here on Visual Studio, maybe the structure pane be down here. It's possible to kind of move the windows around and kind of save your own preferred layout. There's also a Visual Studio tool and key mapping that you can set up on the IDE as well. I'm just going to leave it on the default layout that I'm familiar with. But let's just jump straight in, create a blank application. And I'm literally just going to do here a really simple edit control. Let's do a list box just to put some values into, and a button. So let's go ahead and align the edit to the top. And what you can do is you can see here how it's going to look on multiple different devices. So this is kind of the Windows desktop look and feel, and this is how it would look currently on different mobile devices. So you can actually, let's just rearrange these a little bit. You can actually put this on a separate window, so you can see a live preview. I'm actually going to go ahead and let's just align this to the top here. I'm pretty familiar with laying bits out now. You kind of get used to how to lay things out to work quite quickly across multiple platforms, and it's very, very easy using different anchors and alignments, which, again, same kind of things that you're used to using in Visual Studio. I'm going to go and set some margins on each of these controls. Let's just make the button a little bit bigger, and let's go ahead and change the text property of this to add item. And here we can use the edit control. We can use the text prompt to be enter item value, and we can see how this is looking now on Android, and we can see immediately how it looks slightly different on iOS and how it looks on Windows desktop. You can turn on and off the different devices that you want to be able to work with here. So let's just go ahead now, double click on the button, and we're just going to tell it that we want to take the value from edit one and add it to the list box. So we're just going to do list box one dot items dot add using code completion, and in here we're just going to put in now obviously edit one dot text. That's as simple as it is. So let's just go back to the project manager here. We've got targeting here for Windows. So let's go ahead and run a Win32 version of this application. Hello world. And we put C or Delphi. Pretty nice and easy. Now, if I want to see how that's going to run on a physical device, I can just go and choose one if I have one connected to my machine. or I'm connected up to my Mac here using PA Server, so I can actually see the different iOS devices. So let's just go ahead and run, let's try an iPhone 4S, that's a nice small device. And what this is doing, this is compiling it now on the Windows machine, using the same compiler that Xcode uses, and then launching that across on the Mac, on my simulator. So hello world, and I'm now using the iOS simulator to be able to add the items directly into the list box on the screen. So say it feels very, very familiar to C# developers to be working with Delphi. Now we do have full language support across all of the platforms that we provide for. So that's Windows, Mac, iOS and Android, has full platform support for all languages. Now that includes the ability to debug on all of those platforms, and you can use PA Server, which is there on the Mac, even to remotely debug a remote application running on a Windows machine, for example. But just plug the device in, and you can then use the native debugging to get directly in, see the full call stack, everything around the code executing on that device. And when I say full language support, it's really important because unlike some of the other platforms, I know Xamarin, for example, allows you to compile for iOS, which you have to do to actually go on a physical iOS device. We offer full language support there with generics and reflection and remoting. That's something that you can do with Delphi on all platforms. We also have great database connectivity layers, and that's the original foundation really of Delphi, is the great database connectivity. That's available across all the platforms as well. Obviously where drivers permit, you're not going to be able to directly connect to a SQL Server database directly from an Android device, for example, because the driver doesn't exist there. So you would use things like web services and REST to be able to communicate back and forth, and they're fully supported. And the great thing is the backends that you're building using those technologies today, you can go and consume super easily out using Delphi today. Now, one of the big things around the language is interfaces, and interfaces are a great OOP pattern that basically you define a contract and then you say, is this contract supported? And we have to do a lot of work under the hood on certain platforms to be able to provide a common interface that you can code to. But that's all taken care of for you. So if you want to go talk to the camera or the accelerometers or send a notification, they're all interfaces that you can integrate into your application development code. You can query the platform to find out if that interface is supported. So for example, you can in code say, does this device support telephone dialing? And if it does, then go ring this telephone number. If it doesn't, for example on an iPod, then you can get that programmatically. So you can then disable the button to call on the user interface. Now, the other great thing with what FireMonkey provides, the user interface, is that there's a whole stack of, I think it's over 50 no-code hardware effects that you can apply onto user interface. Little glow effects to say this needs to be filled in, for example. There's a whole set of animations and 3D programming capabilities as well. But they're all built in directly ready for you to use. So as I say, great easy access right into the device, into accelerometers, into advertising, into Bluetooth, Bluetooth LE. There's components for easily working with beacons, which are one of the most cool modern things that are jumping up around the place at the moment. Great abilities connecting to the camera, use HTTPS, REST, etc. So I've mentioned beacons a couple of times. Let's actually get in and build an application from scratch using them. So I'm just going to go create a blank application here, and let's pop down a button at the top here, and let's put down a memo, and I'm going to align this to client, and let's just put a margin at the top, maybe about 50. There we are, we can see the button okay now. And on the button click, I'm just going to enable a beacon component. So let's put the beacon component down. And what the beacon component enables me to do is to quickly get notification of beacons, Bluetooth beacons. So we're just going to do an enablement in here. So we use the assigner operation, which is full colon in Delphi, full colon equals. And then on the component itself, we can use the on-enter and on-exit event. So there's the on-enter and there's the on-exit. And here we can see the parameters that are passed through. So we're getting a beacon, which is an iBeacon, and we can click all the way through the source code here. So we can go find out that an iBeacon is an interface. There's a number of different methods that are supported by it, additional properties as well. So let's go ahead and in here, this is the enter event. We're just going to just go and put some text into the memo. And on the second line we can just say, right, let's put the beacon's GUID in. Now each beacon has a GUID, and you can actually set up that all your beacons run the same GUID, which is quite often what people do, to identify specific beacons that you're interested in, because there's a lot of beacons out there that you're not interested in, and that way you can find only the ones that are relevant to your software. And I'm just also going to put in the major and the minor string that comes from the beacon. This would help, for example, identify my beacons in this store in this location. So you could say, for example, major could be the floor number in a shop, and then minor could be the zone within the shop that you're interested in. And then that way you can identify when somebody's got to the correct area and then give them an alert of some kind of special offers that are running or something. So here I'm just going to go and change the death timer here to 1 just for the purpose of the demo, and let's go and run this out onto my Mac where my Bluetooth is connected. So I'm going to click the button to enable the beacon scanner, and I'm going to plug my beacon in. Now I'm expecting to see 2 enter messages appear, because the beacon I have here transmits both iBeacons and alt beacons, and I'm monitoring for both on the extended type. And if I unplug the beacon now, within a couple of seconds now, because I've set the death timer to 2, we should now see the exit events appear. So what I can do is I can just copy this GUID value actually, and that GUID value is the ID for the beacon. We can also see the major and minor is 1 and 1 here, because it's just a single beacon. And what you can do is in the monitorized regions, I can come in, I can set up, as I just have now, the beacon, and I can say what type I want it to scan for, and then I can say to the beacon, I want you to be in kind of standard mode. Rather than scanning for each one of these types, if I click now the button, it will only come up once, and then as I remove to exit, then I only get the single event. Okay, so I could go through the samples for Bluetooth all day long. I do want to finish off just by showing you this out onto mobile though. But with all the other devices and sensors, and this is just a small snippet of them, there are so many, have a look in the samples directory. So I'm just going to plug my iPad into my machine, and we should see it just pops up here. Great. And let's just jump back to the IDE, and I'm just going to refresh the target devices. Now on my Mac I have a copy of PA Server running, which is the bridge between my Windows machine and my Mac, and that's important because it then tells me what devices are plugged into the Mac, and it allows me to run my application directly out to the targets that are connected to the Mac. Now with any native iOS development, it has to be code signed on Apple hardware. So we do the development, the building, the compilation, all on the Windows machine, and then the package is deployed onto the Mac, code signed, and then added onto the physical device. So I'm just going to open up Reflector so you can see my screen. And let's just mirror my screen here. And here we have Project 2, which has just been deployed. Now as it starts up, it's asking, do I want to allow it to use the Bluetooth? Say allow, and I'm just going to hit the button to do the scanning, and there we are. We can see now that the beacons come up, and if I now take that out of range, it would then come up with the exit message as well. So these cross-platform capabilities are really, really powerful within Delphi, and as I say, really, really simple to pick up and understand, very familiar to C# developers. But what are some of the other reasons that are driving people to use Delphi rather than some of the other alternatives? Well, Apple came out with this really profound statement at their Worldwide Developer Conference back in 2012. After doing a lot of research, they came out and said, we feel so strongly about ARC, automatic reference counting, being the right approach to memory management that we have decided to deprecate garbage collection completely in OS X. Now, once the standing applause finished, it was quite clear, having a look at some of the research that's been done around explicit memory management, why ARC is the right way to go. And Hertz and Burgers have done a really good report quantifying the performance of garbage collection versus explicit memory management. And basically, if you're using a garbage collector, you need a lot more memory. Once you hit about 5 times the required memory for the application, a garbage collection technique can partly improve performance, but you need 5 times the memory. When you only have 3 times the memory, the application is going to run 17% slower. That's almost like a fifth slower. But when you've only got twice the required memory, the impact of running a garbage collector is about 70%. It makes the application 70% slower. A big part of that is, when you're short of memory and you're running a garbage collector, it can start forcing things to page in and out of disk. There's some pretty kind of fundamental issues behind running garbage collectors, especially when it comes to mobile. And with Delphi, yes, we support ARC. We have a blazing fast ARC implementation on iOS. But when it comes to Android, where Java developers currently use a garbage collector, anybody who's using Xamarin is going to be using a garbage collector both on iOS and Android. In fact, there's an additional garbage collector on top of the one that runs within the system that those platforms use because of the virtual machine element they have. But with Delphi, we are running ARC on both iOS and Android, providing blazing fast memory management across the mobile platforms. Now, I know memory management isn't the most sexy topic to talk about, and it's not something that's very tangible to see immediately on some slides, but it is something that has a huge impact on the application. But something else that has a huge impact in terms of what you're able to produce and the speed you can produce it is how easy your tools help you prototype what you're trying to develop. And that's something that Delphi has always done very, very well, and that rich heritage has been brought to mobile, and we have some very, very clever tools, some very unique tools on the market for allowing us to see a live preview of the different look and feels for the different platforms that we're targeting, and also to be able to put sample data into UIs as we build them to see how they're going to react to having data in them. It's not always the easiest thing to see a just a bunch of controls without seeing live data around it. And the prototyping capabilities within Delphi allow you to really get hands-on and have a very tactile feel of a prototype that is then very easy to switch into a production version, sometimes with just a single line of code, to swap prototype data with real data. So let's have a look at some of the prototyping capabilities around visual live bindings, the prototype bind source, and how they all connect through with the multi-device preview as well. So first off, let's just go ahead and I'm just going to close the projects that I've got open here, and I'm going to go ahead and create a new application. So I'm going to build a master detail relationship application here. I'm going to start off with a tab control and a couple of tabs. Now if I go to the multi-device preview here, I've taken off the Surface Pro. I'm just going to leave an iPhone and an Android device just for whilst I'm prototyping. Let's just have a couple of those here. And that'll give me an immediate bit of feedback about how it's going to look on the two different platforms. And I can then add some more devices in as I get going. But I'd normally have this on a separate monitor with a few more devices and running slightly bigger. But this is perfectly great. So we can see here immediately the tabs at the bottom for iOS and at the top for Android. And that's because the tab control itself has a tab location set to platform default. Now I could enforce them that they're always going to be at the bottom, or they're always going to be at the top, or there's always going to be none. I've got dots when there's none, top for example, but I'm going to stick with platform default just so that's sensible. And on the first page I'm going to put a toolbar at the top, and into the toolbar I'm going to just put a label. Now I'm going to get rid of the tabs eventually, so you'll just have to bear with me for the moment. Let's align this to the contents, and down here we've got a style lookup. So I'm going to say this is actually a tool label, and I'm going to say right, the text is going to be my core app, and the text settings here I'm going to just align these to the center. So we can see immediately this is the Windows look. If I kind of switched over to iOS, you can see how it would look on iOS or Android immediately here. I'm just going to leave, so we've got three different versions here, but we can see here now I've got my call app, and the tool labels have become kind of bold on the platform where they need to be bold, as the default would have it. Now I do want to have a list in here, so I'm going to use a ListView control and align that to the client. And I say it doesn't really show anything yet, and this is where prototyping really becomes interesting, because I'm going to use a prototype bind source, and I'm going to add in, we have a few different fields here, and these are prototype field generators. So all they are is just different field types. We've got strings and currencies and pictures and integers, and you can add generators with, or links that have got no specific data in them. But I'm going to use some of the generators. I also kind of like the Lorem Ipsum one, so see if I can. I'll add one of those, and then let's just come back and add in the other ones again. So the contact ones. Now I can come in here and I can rename these, so I could add this as info, and the picture I could just leave as contact bitmap, and that's fine. The contact name, I could have a property that's kind of maybe full name on my object, and that's quite important. If you name these to match the properties of your objects, then it'll actually just suck the data directly through and put it onto the screen for you later on. So that'll do. I'm not going to spend time just changing those now. But what I'm going to do is I'm going to bind visually. So with my list view here and my prototype bind source, I'm just going to say let's keep these in sync. And now we're beginning to see that we're going to have some data. Let's have the full name as the item text. And we're now beginning to see how it's going to look on the different platforms. I can also come in here and say, well, let's go ahead and take the list view control and let's adjust the item appearance. Now you can create a dynamic appearance. There's a whole number of pre-built ones, or you can do a custom one. I'm just going to use the image with a list item, which is a very common one to use. So I'm just going to take the small bitmap here, and I'm going to link that now to the item bitmap, which has now appeared because I've changed the style. Let's just lay these out so it's a little bit easier to see how that's coming through. And now we can see how my app is beginning to shape up on both the platforms. And we can see there's a slight difference between the way the information detail is presented on both platforms too. So now on the actual far side, I'm going to go and link to a new control. And I'm going to link the full name to an edit control. I'm going to add a control label, and I'm going to now just drag that onto tab 2, so it now becomes a child of tab 2. And let's go ahead and align this to the top. Now because we've got the label at the top, I'm going to give it a little bit of buffer at the top. And let's go ahead and add the contact title in, and I'm going to link this to a new t-edit control as well, and let's put this onto the tab control as well, and again we'll give it a bit of a buffer at the top and align this to the top. And finally I'm just going to add the bitmap picture in, so let's add that to an image control. I'm not going to worry about a label because we've got the label on the screen here. I'm just going to tell this to go in the center, and we can see now how this is building up on the different platforms. How it's going to look. Now the only thing I do need to do is just go ahead and obviously put that image control into the tab. So very quick and easy to see what's going on with prototyping. And you can see how it's going to look on both sides. Now the only thing that I would like to do now is I'm going to add in a toolbar. Let's put a toolbar in here as well. And what I can do is I could just say make this most top, and that would then appear at the top. I'm going to pop a button in because I'm going to use a back button. So let's align this to the left in there, and we're going to create a style look up here of a toolbar back button, and you can see that's now picking up the correct style for each platform. And we need that to be able to kind of do some movements, so I'm going to add in an action list, and I'm going to create a standard action, and in here I should be able to find we have some tab change actions. So I want this to be the tab previous tab action, custom text, I'm just going to put back, and this button I'm going to link up to the previous tab action. So I can now see how that's looking on iOS and Android, and that's all looking pretty decent. On the list view, what I want to do is on item click. So as we click onto a new item, I'm just going to tell the tab control here to set the active tab with transition to be item 2. Now obviously I'll probably name my tabs properly to give me some nice maintainable code, but here I can just say I've got a T tab transition. I'm going to have it slide in, and if we have a look at the action here, it's normal direction and it's a slide transition already, but you can change that quite quickly here as well. So let's just quickly prototype that here on Windows, and if I click on Paul Davis, I've got Paul Davis, and if I click on Adam Anderson, I've got Adam Anderson. My button doesn't seem to be working though, so let's just go back and make sure that my action is connected. It just needs to link it to the tab control. There we are. And let's go ahead and tell the actual tab control itself. Now I'm pretty confident, so let's go ahead and change our tab position to be dots, which just kind of gives the user some input to where they are. And there we are. We can now see that we're working quite nicely through, and we've got some prototype data. You may decide that actually I want to have a feeling like we're off the edge slightly. Great. Is that enough? And now it's just a case of saving our project, calling it something sensible, and running it directly out onto our mobile device. So let's go ahead and connect up to our iOS target here, and I'm going to use the iOS simulator this time, so let's just use the iPhone 4S and go ahead and run this out onto iOS. And now you can see the iOS simulators starting up from scratch, and here comes the project. And great, that's all working. Now I might want to just adjust the height I've given my controls. And I might want to just do that on iOS only. So what I can do is I can, let's come create an iPhone 4 specific template. And I can now come in and let's give these a little bit more space at the top, and let's just move the labels up just a little bit and make them a little bit wider. Cool. And rerun this out onto iOS. And now we can see that that has actually moved up a little bit nicer and is looking better already. Okay, so I would probably say do the changes on the master wherever you can, and then only have specific views whenever you need them. But I'm going to go ahead now and just show you where you could change this into live data using the prototype bind source onCreate adapter. In here we have a bind source adapter, and you can create a bind source adapter, link it to a list of objects, and those objects, if they have fields that match up the generators in the prototype bind source, will then just link those to the screen at runtime. So I'm not going to do that right now, but as you say, it literally is a single line of code in here to create a bind source adapter if you have a matching object to go onto your screen. So one of the other reasons many developers are moving to Delphi with their .NET application for mobile is that they're still able to keep using their .NET middleware that they've been building. So you can take your existing code with you simply by consuming it within a Delphi client. So if you're building web services or REST services using XML, JSON, you can easily consume that into Delphi with REST clients. So I want to show you quickly an example where this has been done. Microsoft has some great middleware systems out there, the Azure translation services, for example, and they're using a mix of XML and REST to be able to provide out the data services, and you can consume that really easily into Delphi. And there's a downloadable sample on my blog at delphiable.co.uk that you can go and grab, but I'm just going to show you that quickly here. And beyond that, we'll also talk a little bit about working with JSON and being able to convert JSON into Delphi classes very, very easily. So I've loaded in here, I've got two versions of this project, one which was just my testing, and then I actually converted it into some components which you can download, some classes so that you can use in your application, and one that manages the authentication and refreshes that as it's required by the actual API that we're connecting to, and then one that passes the XML data packet that's returned. So let's just quickly have a look at the initial sample that I did. Basically, there's two parts to this. First off is authentication. So the authentication requires two parameters, client secret and client ID, which are passed in. And then if the REST request is executed OK, we then check for access token that's been returned. And if it's been returned, I then just set up the other requests that I'm going to use with the token. And then just for sampling, I've just got a couple of lines to put it out onto the screen after it's been decoded. And then when we translate something here, we've got from and to, and then the string that's being translated. And literally that's all we need to do is the visual live bindings is setting the parameter for the actual text value for the hello world, and then pulling that back out afterwards. So if we have a look at binding visually, we can see that the text is just being, the text parameter is just pulled straight out. In fact, I could bind the from and the to parameters directly to these UI controls as well. That'd be even less code. So let's just run that, and we can see that this is actually now working with the Azure translation services. Let's first of all do the authentication. I've got a hidden region that's just doing my hard coding my identity and my code in, and then translation from English to Spanish, translate, and we can then see the return data packet, which is an XML string. And yeah, that is as simple as it is. Now with the version that you can download, it's basically using the same components, it's just wrapped them up. And let's just do hello world this time, and we get our value back. But this time it's just being wrapped up into some really nice and easy to use components, where we have a token manager for managing the token, and then some additional bits fetching the available languages and implementing the service a bit fuller. But all of it based off the back of these REST components. Now let's have a look at these REST components. So the base part here is calling the API of the Microsoft Translation Services, and we then have a REST request and a response. The request here calls the translate API and passes in some parameters, and you can see the parameters are just defined in the text string here, and we can then define the parameters, different types of parameters. So there's URL segment ones, there's also HTTP header, so that's where the authentication one was being set earlier, that's part of the packet that's sent back. And you can see the current values that have been set up using live bindings as well, which is pretty cool. And then when that executes, it then returns back a data packet. And if I put the authentication header in here, I'd then be able to run this at design time as well, and fetch content back and see the translated content at design time. So just to see what I've done with the XML in here, because the Azure one returns an XML packet, which is slightly confusing from a REST service, but what we can do, it's not a problem, we just use the XML DOM. So here I've just done a simple helper to take XML and convert it to a string, where we just load the XML in using an interface to the XML DOM, and we then just find what we're looking for. I'm just checking here if it's an array of strings or if it's a string, and then just getting the value returned back. And that's pretty simple to implement. We have multiple XML DOMs that you can work with. Obviously on Windows you can use the MS DOM, which is pretty quick. And then on other platforms, just in the initialization here, I'm just changing the XML DOM to be the ADOM implementation, which is pretty quick across all platforms, but not quite as quick as the Windows one on Windows, so or from what I've checked with it. So yeah, I can choose which one I want, where I want to be, and then just get that back, which is pretty cool. So yeah, pretty straightforward. If I do want to import WSDL documents, then we have a whole web services section here. I can import WSDL documents, just put the URL in and pull that in, and that will then give me an interface directly into that with the class structures. If I'm going to be working with JSON, however, then there's a project for converting Delphi, for converting JSON code into Delphi classes. JSON to Delphi class is what it's called. That's on GitHub, and you can use that to generate a unit in the same way that you kind of generate a set of classes from a WSDL document, which is pretty cool. So that kind of demo was a mix between using the new REST components and then once you got some data back, doing some old style XML work with it. But anything that's returned back as JSON now is very, very easy to work with. So you can just do take a JSON string, convert it into an instance of a class. You can take an array of JSON data and convert it into an actual physical in-memory data set that you can then save to file, load from file, that you can do filtering on. If you get multiple different data sets, you can then do some local SQL against those different data sets joined together to be able to work against them. Some really kind of cool stuff that you can do with JSON. And with any kind of data really. And obviously if you return back a remotable object through a call to a WSDL document, then you can then go and connect those directly up to your prototype bind source, and off you go and use them. Now, one thing that is kind of a fun video, bit of a side thing that Jim McKeith did was the 5-minute REST challenge, and that's using those components to connect up to a true REST JSON web service for surfers, to kind of have a look at some different data and visualize it and get it out onto iOS and Android. So the link's on the bottom of the screen there if you wanted to have a look at that. We'll also try and get that into the chat if you're watching this live. So let's kind of summarize really what we've had a look at and what we've been speaking at in the last hour. Delphi and C# have a very common ancestry. They're very familiar to use either or. Developers feel very familiar straight away because of this kind of object-oriented design, because of the way that the types are declared in the same way, because it's property method event development. Delphi brings the best to mobile by providing native compilers across all the platforms that we support, which means you've got a common code base, you've got full language and debugging support everywhere. So you can get right into the cool stack and see the ARM chipset code and the Intel chipset code on Android and on Windows and so on. It's got blazingly fast memory access on iOS and Android with Arc implemented there on both platforms without any garbage collection. There's no virtual machines, there's no bits in the way that are kind of preventing you getting directly to the metal. And if you do want to go and call a specific API on the platform because you're native, you can do so. We've also had a quick look at the rapid prototyping that you can do with the prototype bind source and visualized bindings. And we've also had a quick look at how we can connect up to an existing .NET service, in this instance one that's returning XML packets through standard REST interfaces like the Microsoft Translation services from Azure. So all in all, there's so much here for C# developers to be able to bring their code with them, to be able to work in an environment that feels very familiar very quickly. And if you want to be able to get up to speed with the languages, then there's a great Object Pascal language guide from Mark Ucantu that you get free with your registered version at the moment. So definitely worth having a look at. So really now it's time for any questions. If you're watching this live, then please go ahead and use the chat window and post your questions in. If you're watching this on replay, then sorry I'm not here to be able to answer your questions at the time that you're watching it, but please do go ahead and either email me on stephen.ball@embarcadero.com or send me a tweet at delphiable.